Good afternoon, ladies and gentlemen. Welcome to topic 3, lesson 2, under indices or index notation. So, in the first lesson, which is lesson 1, we looked at the laws of indices. We looked at a number of them. Should be 9 laws in total, of which you need to be familiar with all the 9. Okay, so in today's lesson, we're going to look at, this is the last part, by the way, we're going to look at the equation involving indices. This is the last part of this topic. Then we'll go to topic 4. Now, we have two types of equations that involve indices. We have this kind, where A is a whole number, okay? Then we have this kind, okay? For example, we can have a question like 2 to the power x is equals to 4. Then here we can have x to the power 2 is equals to 16. So they are different. They're not the same. Check, here x is the power, here x is the base. So they are different. Now, check this. These are very simple. These are very simple as long as you understood what laws of indices are. If you have, they've given you 2. They're saying 2 to what number is 4? Okay, this is very simple. We looked at 2 to the power 1 is equals to now a number itself. 2 to the power 2 is the same as 2 times 2, which is 4. Now here they have given you the answer. The answer is 4 when 2 is raised to what power? 2. Okay? So this is what is here, this part, this side. Right? This is what is this side. Now on the other side is different. On the other side is like this. You're given x, what number raised to the power 2 is giving us 16. You see? It's different from this, but this is also simple. What number raised to the power 2 is giving us 16? 2 to the power 2 is not 16. 3 to the power 3 is not 3 to the power 2 is not 16. 4 to the power 2 is what? 16, eh? But there is a way we're going to use. There's a way of solving these questions without just guessing, or struggling. That's why we have laws of what? Indices. Very, very good. Now, these are all these are examination questions. This is the 2024. Yes, 2024 GCE. 2024 GCE. Now, copy. I want to have enough space for solving these questions. Have you copied this? Yes. Okay. Since you've copied, so what you need to do is just to start solving. So here they're saying, look at what they're saying. They're saying to solve for x, make bases the same, and then get the what? The powers. Okay, this is this part. Okay, so let's done with this part, then we'll go to the second part, which is B. Okay, all right. So let me just create space here. Okay, now look at this. The first question A is 2 to the power x is equals to what? 4. Please, this is not the same as 2x is equals to what? 4. Why? 2x is equals to 4. You simply divide by what? By 2, then these 2 and these 2 cancel. X is equals to 2 into 4, 2i. But this one is not the same as this one. This one is a power. So what we're going to do here, you're going to make bases the same. Are we together? Bases the same. So since this is 2 to the power x, can we change 2 to a base of 4? No. But 4 can be changed to a base of what? 2i. 4 is the same as 2 to the power 2i. Okay? 2 to the power 2. Now we have the same base. When bases are the same, we get the So here the power is x is equals to 2. Can you solve here? No. So the answer is what? 2. This is x is equals to 2. That's the answer. So if we are to substitute 2 here, if we are to substitute 2, is it giving us 4? So x is 2. Where there is x here, if we are to put 2 here, 2 to the power 2 is true. Why? Exactly. Okay? Do you have a question here? No. Okay, let's go to the next. The next one is the 2024 GCE one, which is B, is 81 minus 20 what? To the power is equals to 0. Is it visible there? Okay, is equals to 0. Now, when you look at this in the exam, as long as the power is a variable, what you need to know, just know that this is indices. The question is involving what? It shouldn't confuse you. You should just have two terms, the one on the left and the other one on the right hand side. All right. So here, what you can do, you can take this negative 27 to the other side, right? And here you remain with 80 is equals to positive 20 to the power x. You see? Okay, as simple as that. Now, or you can take 81 to the other side, right? Just the same. Or you can take 81 to the other side. Okay, let me erase here if you have copied. Someone may say, what if I just remain with I take 81 to the other side, you remain with negative 20 what? To the power is equals to negative what? 81, right? Then remember, the base should be positive. So we're going to divide by even there negative 1, right? Okay. Then we remain with 27 to the power is equals to negative 81, right? So you can work with this or this is just the same. Are we together? So if I were to go with this one, they're saying, look at this. Remember, bases are not the same. Make the bases the same. By the way, there are a lot of ways of solving such questions, but just to follow what I'm giving you right now. Look, this is 27. This is 8 what? 81. We can't change 81 to a base of, 27 to a base of 81 and 81 to a base of 27, right? But we can reduce both to a common base. Which one is that? 3 or 2? 3, right? 27 is the same as 3 to the power 3. Then there is x, right? Don't forget the x, right? There is x there. Is equals to 81 is the same as 3 to the power. Simple. Okay? Same as here. 81 is the same as 3 to the power. 27 is 3 to the power. Then you have x aside. Are we together? Now when bases are the same, what do? You get the powers. Very good. You get the powers. So here we're going to get the power. This is 3x, right? Is equals to, but it's not yet done, right? Here we can divide because this is not 3 to the power x, but 3a over 3 over 3. This 3 and this 3 cancel. Therefore, the value of x is equals to what? 4 over 3, right? I'll end it here because I want to show you something, right? I want to show you something. Even here, just the same, right? Because here it will be 4 is equals to 3x over x is equals to 4 over 3. Let's try it. If at all, it's going to give us 4 over 3 if I substitute x, right? So here they're saying is 27x, right? Is giving us 81. 27, x is what? 4 over 3. Do you remember that law? Let me use this parting. 27 to the power 4 over 3. 4 over 3. It should give us 81, right? So we want to prove. Now, do you remember that law which states that when you have a base raised to a fractional power, the denominator of the fraction becomes the root? Okay. So here the 3 will be the root, and with the cube root of 27 to the power 4. Which number, when you multiply itself 3 times, would give us 27? 3. 3 to the power 3 to the power 4, it means 3 times 3 times 3 times another. What is 3 times 3 times 2? What is 3 times 3? 9. Times 3? Times 3? 81. So our answer is what? Correct. Correct. Okay, but in the exam or in the test, don't prove. Aye, you waste your time. Okay. Now, to simplify this one further, look at this. Just to simplify this one further, you can leave it as a mixed what? Fraction. I left it here just to show you, to use it to prove the answer. 3 into 4, remainder over 3i, whole number, same as there. Okay. Simple. Okay. Simple. Let's go to question C. These are examination questions. These questions give hell when if you don't understand, if you don't know how to go about them. They don't miss in the exam. It's either this side, this type, or that type, that side. This type is simple. It's simple and straightforward. This one, at least it gives a little bit of calculations where you're supposed to calculate. Can I raise? Yes. Okay. Okay, so C, they just want to confuse you, saying given that the square root of 2 is equals to 2 to the power x, find the value of x. When? Look, this one, as long as the power is unknown, that's not that the indices. Yes. Now, if I give you something like this, 4 raised to the power 1 over 2. This one is the same as the square root of. Are we together? Yes. The 2 is invisible and the 1 is also invisible. So meaning you have a clue here. This is an examination question. So look at this. So this one can be written as 2 raised to the power and invisible over simple is equals to 2 to the power. Our base is the same. So you can get to what? 1 over 2 is equals to, therefore, x is equals to 1 over simple. That's to confuse you. Yes. Okay. Then D is 125 to the power x is equals to 1 over 25. So always, wherever you go, don't forget the laws of what? Indices. Now look at this. This is 125 to the power x. This is 1 over 125, right? Now check. Let's do this. This 1 over 125 can be changed to a negative power, right? As 25 to the power negative what? 1, Yeah, 25 to the power negative 1. So you can, this fraction can be written, so here you can say 125 to the power x is equals to 25 to the power negative 1. Are we together? Now, let me just write nicely, negative 1. Now we can now solve. The base we have 25, 125, there we have 25. We can't change to 125 to a base of 25, 125, but both can be changed to a base of 5. Are we together? 125 is 5 to the power 3, right? Yes. So x, right? put it in brackets, is equals to 25, just 25 itself. 25 is 5 to the power what? 2 times negative. Don't forget about the negative, right? Now, the bases are what? Are the same. Just play with these questions. Mathematics will be okay. So 3 times x, 2 times negative 1. Then what do you do here? You divide both sides by 3, like this. Then this and this cancel. Therefore, x is negative 2 over. You can still prove if the answer is what? Correct. Okay, at your own time. You can prove if your answer is correct. I can erase this question, right? Let's prove if our answer is correct. 125, what is the value of x? Negative 2 over 3. So let's solve this one, and it should give us 1 over 125. Okay, so the root here is what? 3. The cube root of 120 to the power negative. What number when you multiply itself 3 times should give us 125? It's what? 5. 5 to the power negative. Check. This is a negative exponent, negative power, and it's not a fraction. It's not a fraction. So what you do, introduce 1. This one will be 1 over 5 square. 1 over, what is 5 squared? Oh, 25. 25, Same, huh? We're doing the correct thing. Okay. We can now go to question what? Oh, to the bonus square. Bonus question. This bonus question came in 2017? I should be 2017, okay. 2017. But it's an examination question. Now they want to confuse you with decimals. Not you. You cannot confuse. Okay? You cannot be confused. So now you cannot. So look at this question. This is a bonus question, and it's 10 to the power x is equals to 0.0001. How many zeros? 3 zeros after decimal point. So an equation. Solve the equation. Now it's simple. Just write this one the way it is. Here's 10 to the power x is equals to. Write this one in standard form. In standard form, So you have 1, 2, 3, 4. 4, look at this. 4. So we're going to write 1 times 10 to the power negative 4. When you're going to the right, it becomes negative, right? This one is this one. Times 10, always times 10, to the power, the number of points, So 1, 2, 3, 4, the number of steps the point has moved. Okay? Now, check 10 to the power x. You need to make basis the what? Exactly. 1 times 10. By the way, here, you cannot multiply since this one is as a power. In other words, you just have 10. Okay? Here you just have 10 to the power negative what? 4, in short. Then are the bases the same? There's the same way. Therefore, x is equals to negative 4. Let's prove this one as well. Why? Mathematics is about proving. So 10 to the power negative. Okay? It can be written as 1 over 10 to the power positive 4. Am I right? And erase this questions. Okay. Then, 10 to the power 4, it means you have 4 other zeros, right? Is 4 other zeros? Something like that, right? So you have 1. So it means 10 times 10 times 10 times 10. How many times? 4 times, right? 4 times. 10. Let me show you. Times 10 times 10 times 10. Okay, so you just write 1 with the zeros, 4 zeros, 1, 2, 3, 4, 1, 2, 3, 4. Am I right? Oh yes, 10 what? 10,000? 10,000. 1 over 10,000. 1 over what? 10,000. Now they left it as what? As a decimal. Are we together? As a decimal. So 10,000 into 1 is 0. Right? Okay? 0 point. Then this one into 10, 0. Into 100, 0. Into 1,000, 0. 0. Then, oh, supposed to be like this. Then into 10,000, 1. Okay? So in other words, you've copied the question, the solution. So in other words, check. In other words, if you don't want to leave it in standard form, standard what? Standard form, you can solve it like this. 10 to the power x is equals to, it has moved 4 times, right? So it will be 1 over the number of steps that's moved, which is 10 what? 10,000. 10,000. Are we together? 10,000. Then 10 to the power x is equals to 1 over 10,000 is the same as 10 to the power 4. Are we together? Then you can do like what we've done to that one, 1 over 120, 1 over 25. So this one can be 10 to the power x is equals to 10 to the power negative 4. Then x is equals to what? Negative 4. Okay? You can use this one. Is also accept what? Acceptable. All right. Acceptable. So we are done with the first part. We're done with the first part. If you have questions, ask. So let's go to the second part. The first part was most confusing. Okay, more confusing than the second part. So if you understand it, if you have understood the first part here, the second part won't be difficult. Are we together? Yes. Okay. Now, the second part. Now, what if it's the base that is unknown? It is the base that is not known. You introduce the reciprocal of the power to both sides. What that means is this. The first one. When you have a question like x squared is equal to 16, you quickly square root both what? Both sides, right? Yeah, the square root of that one, blah, 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 x is equal to so. Now, what we're going to do, the reciprocal, this is what it means when they say the reciprocal. Right? They're saying, what base raised to the power 2 is 16? You want to find 4, right? We know it's 4. So, what you do is 2. The number, when you multiply 2, should give us 1. Is 1 over 2 itself. 1 over 2. So if we introduce 1 over what? 2 here, then even this side you should introduce 1 over 2. So when you cancel this one and this one, you just remain with x to the power 1, which is just x, right? Then here we can find the square root of 6 what? 16 to the power 1 is just an invisible what? 1. What is the square root of 16? 4. Okay? 4. The square root of 16 is negative or positive 4. Are we together? So let me give you even 2 options. Negative or positive or negative what? Negative 4. When you square root a number. But when you cube root, you don't have such options. When you square root a number, you have 2 options, positive or negative. Exactly. Can you go to second question B? Oh, by the way, you can only introduce the reciprocal of x if the square root, the coefficient here is 1. When the coefficient here is 1, if it's not 1, make it 1 so that you solve nicely. Look at the second question. The second question is 2y to the power 3 is equals to 54. So here you can't just go directly introducing the reciprocal of what? 3. Because the coefficient of y is not what? 1, eh? So we're going to divide both sides by what? 2, eh? Here you can divide. So 2y to the power 3 is equals to 54 by 2, even this side by what? By 2y. So these 2 and these 2 cancel. Then y to the power 3 is equals to 2 into 5, 2. Remember 1, eh? 2 into 14, 7. So in other words, instead of just giving us y to the power 3 is equals to 27, they've given us this. So this is now where you can introduce the reciprocal. So we have y to the power 3. The reciprocal of y of 3 is 1 over 3 is equals to 27 to the power 1 over 3. So here we're going to cancel the 3 and these 3. Are we together? Then y is equals to, this denominator of the fraction becomes the root, so it will be the cube root of 27, okay, to the power 1, eh? And the 1 is invisible. Now, what number when you multiply itself 3 times should give us 27? 3. So y is equals to, simple as this. So that's the answer. Are we together? Good. So here you don't have you don't have two answers, positive or negative, because this is the cube root and the note is square what? Square root. You should take note when solving equation. Solving equations. Take note of that. The second last question. Oh, we have 3 more. 2 more. 3. So question C is direct. Are we together? Is x to the power half 4. Check. Now the power here is the fraction. Then the reciprocal shouldn't be the fraction. It can be a fraction, but it should be like this. It's 1 over 2, right? So its reciprocal is just 2. Are we together? 2, why? 2. We just 2 over 1, but just 2. Meaning this side also we should introduce a what? A 2. Are we together? This and this cancel. X is equals to 6 ndani? 16. If you put 16 here, 16 to the power 1 over 2 is 4, right? Because we're going to find the square root somewhere there. Okay. Now, let's answer the last two what? The last two questions. The last two questions, so question, let me see, D. Question D is saying we have 2 x to the power 3 is equals to 6 what? 16. Can you go direct and introduce the reciprocal of 3? Because we have the coefficient which is more than 1, right? So first step is to what? To divide by what? 2. Both what? Both sides by 2. Are we together? So these 2 and these 2 cancel. X to the power 3 is equals to 2 into 16, 8. Then when you reach upper, you're going to multiply by its reciprocal. The reciprocal of 3 is 1 over 3. Even here 1 over 3. This and this cancel. X is equals to the cube root of what? 8. What is the cube root of 8? 2. So x is just 2. Exactly. That is 2. If you introduce 2, if you substitute 2 here with x, 2 to the power 3 is 8. 8 times 2? 16. So this is correct. Let's look at the last question for today. In fact, the last question of this topic, indices. Then next we'll go to the new one. New topic. The last question is question E. X to the power 1 over 3. This should be 2021. Should be 2021. Internal. Okay. So x to the power 1/3 is equals to 9. Okay. So here We're going to check first the coefficient of x is 1. Are we together? 1, so we can just go direct and introduce the reciprocal of 1 over 3, which is just 3. Are we? Vamos? Good. So x to the power 1 over 3 times what? 3 is equals to 9 times 3. Are we together? Then this 3 and this 3 cancel. Then we remain with 3. What is 9 to the power 3? What is 9 to the power 3? Let's calculate. Huh? It's 9 times 9 times 9. 9 times 9 is 80 what? So we have 81 times 9. 9, eh? 9 times 1? 9. 9 times 8? 72. 70? So it's 729. Aye, you can confirm that. So the answer here is 729. That's the value of what? That's the value of x. So yes. So you can prove if the answer is correct by substituting x with what? 720? 729. Aye. So you can say 729 to the power 1 over 3. Then you're going to find the cube root of 729. Okay? Aye. So this is your work. You have 2017 GCE, 2018 paper 1, then and those other questions they are down. So that is your work. All the best.